X. We are back with another COMSOL Multiphysics tutorial with carpenter examples. Here we have an impact analysis of a golf ball. During the simulation, we are going to focus on the mechanical impact of when the golf club comes into contact with the golf ball. We also have to note that golf balls has some important characteristics such as the aerodynamics and the mechanical properties, and these influence the outcome of the stroke. We look at the energy that is transferred from the club to the ball. Here are the dimensions of the equipment. We're going to make some assumptions. One, we're going to consider the golf club to be made of steel, and we're going to consider the cover of the golf ball to be compressible, while the inner and outer core, which is underneath the cover of the ball, we're going to consider those nearly incompressible. So we'll use a mixed formulation because of such. And we'll take note that the golfer hits the ball at 90 miles per hour. And also we have to consider friction, because friction is what causes the ball to spin after being hit. And because of this, we'll use a Coulomb friction model. And of course, we need a contact condition, because we are focusing on when the ball and the club comes into contact with each other. Here are our global definition parameters, and all these will be provided in the Word document. Let's jump over to COMSOL and get this done. Let's begin by navigating to the model wizard. For the space dimension, let's click on 3D. And let's navigate down to structural mechanics, where we'll choose a solid mechanics physics. And then click on add. Now let's add a study. So click on study and navigate to general studies, time dependent. And then click on done. This will take a couple seconds to load. Now let's enter our global definitions. So let's go to global definitions, parameters, and here we'll input our global definitions. So navigate to your table that is provided in the Word document and enter those values. So here we'll input the name. Here we'll input the expression. The value is automatically converted, so degrees to rads. And here we'll enter a description. So go ahead and carefully input the other values. Your parameters should resemble these. And now let's navigate to home, our home toolbar, and let's input our geometry. So click on import and let's browse for our geometry. So browse to the folder where you have downloaded your geometry. Okay, so browse and let's import our geometry. Now click on import, and here is our geometry. Now let's rotate the golf club to the correct dynamic loft at impact. So we need to navigate to our geometry toolbar. Before I do that, let me take off this grid. And now let's go to transforms and click on rotate. Now we have our model builder. So I'm going to go home. I'm going to come to Windows, and then I'm going to selection list. I like to have my selection list next to the model builder where we can easily select what we want. Okay, so we already selected rotate from transforms. So now let's navigate to the selection list. So if you're in model builder, go to selection list, click on imp 1. Okay, that is the club, and let's click on add. And now let us go to axis type and change it from Z to Y. And for the angle, let's key in some values from our global definition parameters. So if we go to global definition parameters, you just need to input a name along with the mathematical expressions inside of your rotation angle. Okay, so we have loft minus dynamic loft plus attack angle, and we'll now go and form a union. So let's navigate to form union. It's under component 1, geometry, form union right here. So you click on that, and let's go to action, and we're going to change this to form and assembly, and simply click on build all. Okay, so now our club is now in the position where it's about to make contact with the golf ball. So if I use the left mouse button and rotate, you can see that it's in the position to make contact with the golf ball. For our physics and plot creation, we need to first create some selections. So let's go ahead and create our selections. So under component 1, so here is component 1, here is definition. Let's right click on definition, and once we do that, we now have the option of selections. So for selections, you can simply click on explicit. Okay, another way to do that is come into definitions here and explicit, so you can work with either. Let's give it a proper name. So you can call it club head. And for the geometric entity level, let's go to selection list, and let's select 1, hold control and click 2 as well, add, and go back to your model builder, and we're going to repeat the process. So now we're going to create a club shaft. You can do it by right clicking, selections, and go down to explicit again, or you can simply come to your definitions toolbar and click explicit right here. So I'll go with this way, and let's change the name of the label to club shaft, And for our geometric entity level, let's go to selection list and let's select 5, 6, use Control, 8, and click on add. And now let's click on 9, hold shift, click 12, that's caps error, so hold shift, click 12, and Control and select 14. So we have 5, 6, 8, 9, 10, 11, 12, and 14. Okay. Now let's go to our definitions toolbar once more, and let's add adjacent. And for the name of the label, let's call it club head and shaft. So here, club head and shaft, and let's go to input selections right here, and let's go to add here, and let's select both club head and shaft. Click on OK. So we have created our club head and shaft. Now let's go ahead and create a club for rule. So let's go to our definitions and click on explicit once more, and let's change the label to club ferrule. I said ferrule before, but it's actually ferrule. So for the geometric entity level, selection list 3, 4, 7, and 13, add, and that's it for our club ferrule. And now we need to add a ferrule boundary. The ferrule boundary is adjacent definition, so we are still under definition, so click on adjacent, and let's call this club ferrule boundary, and under input selections, let's click on add, and let's select the club ferrule and click on OK. Next, we are going to create a union definitions, and we're going to do so for our club. Therefore, still under definitions, let's go over to union right here, and let's give it a name. So that's club, and what we want to union is, so click on add, and we want the union the club head, well, all three, so you can click on the first one, hold shift, and click the last one. Okay, and created our club. And next, let's create another explicit. Okay, so let's click on explicit again. We are still in the definitions toolbar, and let's type here golf ball. Let's give it a name, golf ball, and let's go to selection list, and let's select 15, hold shift, select 38, so every one of these from 15 to 38, click on add. Okay, and that's it for the golf ball. As you can see, it's highlighted in the graphics window, and we'll then create a cover. Let's add another explicit cover, and here let's add 15 to 18, okay, and we want the other half of the golf ball. So therefore, hold Control, select 27, 28, and if you use the left mouse button, hold it down and rotate to see what you are actually selecting, and then click on hold back Control on the keyboard, hold Control on the keyboard, 34, 37, okay, actually good error. So now you can hold Control again on the keyboard, select 37, Control. So now you know if you make a mistake, you can simply hold Control and then select those that you don't want. Okay, so let's go 33 and now 38. Okay, and then add, and then let's create our outer core, our mantle. We're going to create another explicit, so click on explicit, and we are still in our selection list. But before we do that, let's give it a name, mantle. Use a caps, M-A-N-T-L-E. Outer core can work as well, just that remember your name. Okay, and for the geometric entity level, 19, hold shift on the keyboard, 22, so 19 to 22, Control 29, Control 30, 34, and 37. Okay, before I add, I'm going to go to transparency in our graphic window, and if you use the middle mouse button and push it, hold it and push it away from your body, you can see the outer core, which is the mantle just underneath the cover of the ball. Now we can click on add, go back to the model builder, and let's go a bit deeper into our golf ball, and that is the inner core. Let's create our inner core. So we are still in our definitions toolbar. Let's click on difference, and for difference there is subtraction and addition. So add and subtract. So firstly, let's call this inner core. Okay, and for the addition selections to add, let's select golf ball. Okay, and for the selections to subtract, let's select cover and mantle. Okay, so if you look here now, we are a bit deeper than the mantle, and that's the inner core. Okay, now let's select union under definitions once more, and we are going to make our core. Okay, so let's call this core, and for the selections to add, we need the mantle, our outer core, and we need the inner core. So let's click on add mantle, which is the same as outer core, and our inner core, and okay. So that is the complete core. Now let's go to explicit once more under our definitions toolbar, and let's give this a name, club face. Okay, and Let's change this to boundary. The geometric entity level, change to boundary. And we need boundary 5 only, so go over to your selection list and select 5 and then click add. Go back to your model builder. And let's now create some grooves. Let's go to Explicit and let's give it a name, grooves. And let's change the geometric entity level to boundary. And let's select boundaries 8, hold shift and select 32. So 8 to 32. Click on add. And then let's select 34 to 48. Add. '50 to 54. Add. As you can see, or if I rotate once more and zoom out a bit, you can see we are actually selecting the grooves. So let's continue. We need the others, therefore let's select 56 to 59 and 63. So use Control, select 63, add, and let us also select 65 to 69 and 76 to 79 and then 85 along with 94 to 97 and 103. Okay, and that looks fine. And now let's create a polished steel. So we are still in definitions, so let's go over to difference, and I'll go back to the default view and let's give it a name, polished steel, and let's change the level to boundary and let's click on add. So selections to add, let's click on add and let's select the club head and shaft boundary. So this actually should be named club head and shaft boundary. Okay, so let's select OK. And let's come down to selections to subtract and let's click add, and we need the club face and the grooves. So we're going to take out the club face and grooves, and if we use the left mouse button and rotate, you can see that we take out the face, which is here, from the actual club itself, and we call this one the polished steel. Okay, and let's go and create some contact pairs. So under definitions, let's go over to pairs, contact pair, and let's change the selection right here to club face, because that is where we're going to have our contact, make contact with the ball. And for the other part, which is here, we need to select the half of the ball that is closest to the face, because the contact is coming from this point to these points. So let's select the others. So let's go to selection list. We already have that open, and let's go down. We need 136, 137, 139. If you use the left mouse button and rotate, you can see, and 141. Okay, and make sure you click add. So we have here, we turn this back on, we have the face, and here if we turn this back on, we have the half where it's going to make contact. Now let's go and create integration. So we can now go over to non-local couplings, select integration, and let's go and change the selection to golf ball. For the material, so let's go to frame, and let's choose material X, Y, and Z, and let's go to non-local couplings once more, and let's choose average, and for the average, let's choose club head. Okay, and the frame, let's choose material X, Y, and Z once more, and we need another average. So let's go back to non-local couplings, average once more. Let us go back to our model builder to see where we are, and let's choose here, we shall select the golf ball. Okay, and change the frame to material X, Y, and Z. Next, we are going to manipulate and add what we need for our physics. Before we set up our physics, let's go to club head and shaft. Let's just adjust the name to club head and shaft boundary. Okay. Now let's go down to our physics. Before we do that, let's minimize our definition, minimize our geometry, and here solid mechanics, let's right click on that, and let's go to material models right here at the top, and let's choose hyperelastic material. Let's go to the domain selection, manual. I'm going to change this from manual to cover. Let's go over to our physics toolbar, and let's select domains, and under domains, let's go for hyper elastic material, and let's choose core, and let's go to the compressibility, right here, and from the list here, let's choose the Hartman Neff volumetric strain energy. And for the bulk modulus, we need to input 1, use the square brackets, gigapascal. We are still under our physics toolbar. Let's go over to attributes and select viscoelasticity. And let's scroll down. Let's make this a little bit bigger. This can become a little bit smaller. And here, let's click on add. And let's key in some values. So for the energy factor, for the first one, 0.26. Let's make this 1 - 5. This one 0.19, and let's click add again, and 0.22, and here 1 to the -4, and here to the -3. Okay, and now let's go back to the physics toolbar, domains, and let's add initial values. So go down to more, initial values, and we're going to add for the structural velocity field for the x. So this is the purpose of the parameters. So you see your names here. So if we go back to here, for the x, I'm going to enter vel x with a short for velocity x, and y remains as is, and of course we're going to enter for the z, which is velocity z, short vel z, in our parameters. And the expressions are already in, so that's basically automatically adding your expressions. So let's go up to the selection and let's choose club. Okay, now let's go to boundaries under our physics toolbar, and let's choose prescribed displacement. So solid mechanics, prescribed displacement, and let's go over to selection list, and let's select 132 to 135. 132 to 135, add. Okay, and for the prescribed displacement, let's select all 3 boxes, and for the x, it will be vel x times t, and I'm just going to copy this, and then I'm going to put it into the z, but I'm going to change to vel z. So vel z times t and vel x times t. And then let's add a contact pair. So we are still under our physics toolbar. So go to pairs and select contact. And for our contact, here we have pair selection, and let's select add contact pair. Okay. Now Let's go down to the contact pair method, and for the formulation we need penalty dynamic. Let's scroll down a bit more. For the penalty factor control here, let's change from automatic to viscous only. And for the characteristic time, let's change from 1 to 0.025. Okay, and now let's add some friction. So let's go to attributes, and let's select friction under solid mechanics, and let's make some changes. So for the friction parameters, let's just enter 0.15. So the friction coefficient 0.15. Okay, so let's scroll back up, and if yours is collapse like this, remember friction parameters is the only thing that we're going to change for the friction. Let's go over to global. So we are still under physics, global, and let's select average rotation. It's under variables, and for the point selection, go over to selection list, and we're going to add our points starting with 158, 161, 164, 166, 169, and 172. Add. And now let's go to the settings. So we are still in average rotation settings, and let's choose the central or centroid of selected entities. So center of rotation, centroid of selected entities. And for the entity level, let's choose point. Okay, and the rotational or rotation model, let's choose finite rotations. Let's now go back to our model builder, and under average rotation 1, select center of rotation 0.1, and here let's select 165. So go to selection list, 165, add. Go back to your model builder, and we'll create our materials. Let's minimize our physics, and we're going to focus on materials now, not materials under global definition, material under components. So let's minimize our global definitions and just focus on this material. So we're going to start by right clicking on materials and select blank material. Let's name this club head, and for the selection, let's choose club, and let's make this a little bit bigger, and let's key in some values. So have 200 to the 9th, and let's make that 0.3 and 58, 78, 50. Okay, for the density. And let's set material appearance data for use our usage in our plot creation. So let's scroll down, and here we have appearance. Scroll down a bit more, and let's choose steel for the material type. Okay, so this looks fine, and we now need to create a cover. So let's create another blank material. If you want, you can go to the materials under the toolbar, so home, definition, geometry, materials, and you can add your blank material from here the same. So let's click blank material again, and let's call this cover, and let's choose cover from the selection, and let's enter some values. So we have here 1.5 to the 10 to the 9th and 1.02, sorry, 0.2, okay, and 1145, okay. And now let's, for the outer core, we're going to add some material for the outer core, or what we call the mantle. So same process applies. Blank material. Let's call this mantle. And for the mantle, let's choose mantle for the selection. So we have some values to be added. So this is 60 to the 6th and 1145 for the density. Okay, and let's repeat the process for the inner core. So blank material, let's call this one inner core, and for the selection, let's choose inner core, and let's gain some values for this. 12 to the 6, 1145, and for the appearance, let's choose magenta. Scroll down, color, magenta. Let's go back up to the mantle. Made a typo right here. So mantle, and for the mantle, let's go down to the appearance, and let's choose color, and let's choose blue. Okay, this is a warning, doesn't mean anything, you can leave it as that, or if you are uncomfortable you can just key in 0 here, but I'll leave it as is. It won't affect the simulation in any way. Okay, next we are going to create our mesh, but before we do that, let's just go over all our materials to double check. It's always good to double check at times. So for club, let's scroll up. So apparent steel, everything else seems fine. Same for cover, same for mantle, and the same for inner core. As mentioned, for lambda, you can actually enter 0 here. I'll leave as is for the mantle and the inner core. Let's go and create our mesh. So let's minimize our materials, and our focus now is on our mesh. So click on mesh, and let's go back home here. So now that we selected our mesh, let's go to sequence, type, and let's choose user control. And now we have the option to click on size. So let's click size. And let's go down to element size and click custom. And now we're going to make some changes for the maximum element size here. Let's make that change to 65 to 0.015. It's okay. For the minimum, let's take off the 8s. So we have 0.002. So that's for the minimum element size. For the maximum element size growth, let's make that 1.6. And curvature factor, let's make it a bit smaller, 0.3. And let's make this resolution of narrow regions, let's make that 0.6. So that looks okay. And let's now go to the model builder, right click on mesh, and let's choose size. Let's put the size 1 on the size, and this is just for clarity. Okay, and let's go to the geometric entity selection, which is here. Let's choose domain, and let's select the golf ball. So selection, golf ball, and let's choose custom, and we're going to make some adjustments here for the minimum element size. So minimum element size, let's click that box, and let's make this 0.0012. 0.0012. Okay, and for the maximum element growth rate, let's select the box, and let's change this from 1.5 to 1.4. Okay, and now let's add a boundary. So let's go to mesh in our toolbar, and let's select boundary, and on the boundary let's choose map. Okay, and we need to select some boundaries, so therefore let's go to our selection list. Let's select 92, 93, so let's scroll up, 92 and 93, 110, 128, and 132. Let's add those, and let's select 133, 134, and 135, and add those as well. Okay, so let's double check 92, 93. Let's see. Okay, yeah, 92, 93, 110, 128, 132 to 135. Okay, let's go back to our model builder, and let's right click on mapped, and let's select distribution, and for the edge selection, let's go to selection list, and 183, 184, scroll down, 183, 184, let's make a big jump to 212, and 242, scroll down, to 42, to 49, 250, 254, and 258. Okay. So that looks okay. Yeah, that looks quite fine. And of course we need to add model builder. Let's go back to mapped. Yeah, that looks good. And let's go back to distribution. And for the distribution section, it is here. So distribution section, our distribution type, fixed number of elements. That's okay. Number of elements, let's change that to 3. That seems fine. And let's go back up to our mesh toolbar. Let's select swept or swept. Yeah, swept. And let's make some changes to the geometric entity level. Let's choose domain for our swept, and let's choose 3 to 14. So 3 to 14. Hold shift and select 14. So 3 to 14, add, and go back to model builder. Let's go back home. Okay. Now let's go back to boundary and let's add a free quad. And boundary selection, let's choose 87. Select add. Okay. And let's add another swept. And this time let's go to domain again. And domain selection, let's make that 2. And add model builder. And that's it for our swept. Now let's build our mesh. So click on build all. This will take a few seconds. Let's make this a bit smaller. And let's go back home. Let's go to mesh 1. Let's check the size. Size 1. So size 1 is the ball. Okay, mapped. Distribution. Sub 1. Okay, sub 2. Yeah, so that looks fine. So once our mesh is good, we can then go and set up our study. Let's set up our study. Let's minimize mesh, keep everything neat, and let's click on time dependent. So on the study, if your study is like this, open it and click step 1, time dependent. You can just make this a little bit bigger for now. And let's go to output times, and I'm going to change this, and let's put that 2 e to the minus 3. And following this, let's modify the time dependent solver so that we can use a manual time control. How do we do that? Let's go to our study toolbar and let's choose show default solver. So here, Normally it takes a while to show up. And let's now go to our model builder and let's expand solution 1. Let's make this a little bit bigger. Under our model builder, let's go down. Now that we expanded solution, let's go down to time dependent solver 1. So click on that, and we have the time dependent solver settings. Let's manipulate some of these values. So from times to store, which is here, let's change this to steps taken by solver, and for the store every ninth or nth, I should say. Let's make that 2. And for the time stepping, let's expand the time stepping. Let's make this a little bit bigger. Let's scroll down. For step time taken by solver, let's make a manual. For time step, let's make that 2.5 to the e minus 5, and let's scroll down a little bit more and see what we have here. Okay, we'll accept this. This looks okay. And let's now go back to our model builder and let's expand solver configuration. Well, we already have it expand. So let's go down now to the time dependent solver. Let's click on that. Let's expand this. And let's select fully coupled 1. Okay. And let's change the values for the method and termination. Okay, so maximum number of iterations, let's make that 25. Okay, and for the tolerance factor, let's make this 0.1. We need to generate the data sets and default plots, so we need to get the initial value. Okay, it's a little bit tiny, but at least we found it. So let's click on that. This normally takes some doing. Now that we have finished generating our data sets and default plots, let's manipulate our label. Let's call that strain solid. And for the plot settings, let's make some changes here as well. So for frame, we're going to change that to spatial XYZ. And for the geometric entity level, we need to make this domain. Okay. To do that, we need to expand selection, and we don't want entire geometry, we just need domain. And for the domain, let's go to selection list and select 17, use control, select 18, 21, 22, 25, 26, and 33. Let's add those, and let's select 34, use shift, select the last one, which is 38, click add. Let's go back to the model builder Let's use the right wheel pan. Let's use the left mouse button and rotate. Okay, so that's our selection. Let's use the middle mouse button, push away from my body, and zoom. And now let's go to the surface and make some changes to the surface. Let's go over to our model builder and let's expand strain. So solid strain, expand that. Our strain solid. Let's select surface. Let's make some changes here. So under expression, let's call that solid point EP3 or that EP3. Okay, and let's look at the coloring and style section. So let's scroll down, and under coloring right here, coloring and style, let's select reverse color table. Okay, and for the quality, let's expand that. Let's scroll down. Let's go to smoothing and change from inside material domains to everywhere. Okay. Now let's go back to our model builder, right click on surface and select duplicate. And let's expand title. So scroll down, title, and let's select none for the title. Okay, so if we go back to default, we haven't complicated anything here. And let's right click on surface. So the same surface here, surface 2. Let's right click on that. And let's choose material appearance. Okay. And we'll accept these and we'll return to our study. So let's minimize these for now. Okay, even the results, let's minimize that for now. Let's return back to our study, and for time dependent, which is here, let's click on time dependent. Let's go down to results while solving, and let's select this checkbox for plot. Let's select that, and where I say update at, okay, let's change this from time stored in output to time steps taken by solver. Okay, and now we are going to compute our study. Note that this will take approximately 2 to 3 hours depending on your computer capacity. If you have a good computer with good clock speed and good RAM, with enough RAM, it will be done much quicker. Okay, so let's go over to compute. You can compute 2 ways. One, you can compute from here, or you can go to your study and you can compute from here. So doesn't matter, let's compute. Therefore, because this is going to take some time, you can get other things done, and then you can always check back to see how your computation is going, because sometimes there can be errors. So even though it might take a while, it's good to check from time to time to make sure there are no errors during the computation. Alright. I should also add that when you check on your computation, don't just look at this bar. Okay, you can actually make this bigger, and then you can check the messages. Okay, and then you can check the progress. You can control if you want to stop something or not, and you can also check the log. A lot of information is displayed in these, so if any error, anything looks strange, you'll know by checking these. So don't just depend on the bar. Now that our computation is completed, we are going to create a material rendering plot and make an animation. So under strain solid, we have settings, 3D plot group. Let's call this material rendering, and let's go down to the plot settings and clear the plot data set edges. So let's clear this. Okay, so if yours is like this, you just open it, and this is ticked, untick it, plot data set edges, and let's now go over to material rendering, right click, and let's choose surface, and let's call this golf ball. And let's go down to the expression, and inside of the expression, let's make this 1, and let's change the title to none. Okay, now let's right click on the golf ball, this one, and let's choose deformation, and let's navigate to scale right here. If it's closed, you open it, take this box, scale factor, and let's make the scale factor 1. Let's continue with navigating to the golf ball once more. Right click, and this time we're going to choose selection, and let's select the selection list, and let's select 136, 137. So scroll down, 136, 137. Let's go down to 161, 163. Add those. So we have, so let's use the left mouse button, and you can rotate and then zoom to see what was selected. And let's go back to the model builder. So that's okay for selection. And let's right click on the golf ball once more, and let's choose image. Here, let me bring this down a little bit. Let's browse, and we're going to import an image. This image is also in the same folder with the Word document and the geometry file. So let's browse for that. So here it is. And then you need to change mapping. So here we have mapping. Let's change this to planar. For the plane type, let's choose the the X Z plane, and for the size, the width 0.03, and the anchor point, we are only going to change the X to minus 0.015. Actually, let's change the Y as well and the Z for this one. Minus 0.03, and the Z should be minus 0.002. Okay, and let's also choose, where rather than use repeat for the extrapolation, let's choose clamp to edge. Okay, and let's go back to our golf ball, right click and choose material appearance, and on the material appearance, let's come down to material list here, and let's choose cover, and for color, let's select this box, use image colors. So if we use the left mouse button and zoom, and then the right mouse button to pan, make this a little bit smaller, this one as well, and close these, but let's just make them smaller for now. Let's rotate a bit. You can see our image is now on the left side of the golf ball. So now let's mirror this on the other side. The same image, let's mirror it on the other side. So let's navigate down to golf ball once more. Here, let's right click and let's duplicate this. Okay, let's close golf ball and let's work with golf ball 1. Okay, now let's open golf ball 1 and let's change some settings here. Let's go up to inherit style, and let's choose plot, and from the plot list we'll choose the golf ball. Okay, it's at the bottom, so let's change this here. Let's choose the golf ball. Let's make this a little bigger, and let's go back here to default just for now. Now let's go to selection under golf ball 1. So let's click on that. Let's turn this on, and let's use the left mouse button and rotate to the other side. Let the mouse button push away for me to zoom. Okay, let's clear this. So here, clear that, because this is selection 1. Let's go to selection and let's select 139, 141, 177, and 193. And let's add those. Let's go back to the model builder. and image, let's click on that. Let's go back home and zoom a little bit, see what's going on. Okay, we need to change the anchor point and also the planar type. So remember, we want to mirror this, so therefore let's choose last time we choose XC, so now let's choose a ZX. Okay, and which will change the Y, so the opposite side, so take out the negative, and the X as well, take out the negative. The Z remains because the Z is the height. Okay, and let's hit plot. Okay, so let's pan, let's zoom, and indeed our image is on both sides. After golf ball, let's go back home and let's continue by right-clicking on the golf ball. So let's close this one. So this is the first one that we duplicate. This is the original. So right-click on the original and duplicate again. So we have golf ball 2, but it won't remain as golf ball 2. We're going to call it club head. And then we're going to manipulate the settings. So this is club head. Okay. And for the, so let's scroll down to the bottom. And the inherit style. Let's make some changes here. And let's select the golf ball. And let's go to selection 1. So let's expand our newly created club head and select selection 1. And from the selection list, which is here, let's choose polished steel. Let's go back to home. We don't need the image on the club head, so you can right click on it and delete. Click yes. For the material appearance on the club head, so we are still on the club head, click on the material appearance and let's make some changes here. So let's select the club head, mat 1, okay, and let's use the plot color. So we have the default polish steel color by doing that. Now let's minimize club head. Let's right click on it and duplicate. Let's expand it and let's go to the label and let's call it club face. Okay, and on the selection for our newly created club face, so click on selection and here, let's choose the club face. And let's go back home, and if we rotate, let's see, we select our club face. And for the material appearance, let's make some changes here. From material, so appearance, we don't want from material, let's choose custom. And for the material type, let's choose some sort of scratch steel. Yeah, this one. Let's go back home. And let's minimize this. Let's duplicate this one as well, clock face. But this time, let's call it grooves. Okay. Let's expand grooves. For the grooves, let's change the material type. So therefore, you have to go down to material appearance. And for the material type, let's choose plastic. And we need some color. So let's choose some sort of dark color. So let's change from white to black. And if we rotate and then zoom, pushing the middle mouse button away from you, you can see we have a realistic look for the club face. And let's go to selection. And of course, we need to change from club face to grooves. Go back home, rotate, okay. Let's right click on, so let's minimize grooves, right click on it, duplicate, and for the name, let's change it to ferrule. And let's go back home, let's rotate, and if you zoom, you can see that the material, the darker side of the material is in the groove. Let's finish up our ferrule. So expand ferrule, selection 1, and let's make some changes. So here, let's choose club ferrule boundary from the selection. Okay. And let's change our environment. So if we click light scene or scene light, you have a bunch of options here. Let's choose outdoor environment. Let's minimize ferrule. And we are in the material rendering toolbar. Let's go back home. Jumps around a lot. And depending on the size of your screen, you might have this little toggle. You want to click on material, and you have the option to choose file or player. Okay, we don't want to export anything for now, so let's choose player. It will take a moment to load. Patience is very important when you're doing these sort of simulation. Now our animation is finished loading, so let's make some adjustments to the frames. Under frames, we have frame selection, and there's number of frames. Let's choose all. And if we click play here in our graphics toolbar, we can click play. It will take a moment to load as well. And here goes our animation. So if we go to, let's try the XZ, maybe the YZ might be better, and then rotate a little bit, and then pan. This might be good. And let's change this to maybe 0.3 to 0.35 milliseconds. It's okay. So we have 0.35 milliseconds here. And if we zoom and we rotate a little bit, you can see the deformation of the golf ball when it comes in contact with the golf club. And you can see all the energy effect or effects within the ball itself. Okay, let's go ahead and plot the elastic and kinetic energy in the golf ball. I should add, if you're not getting any transparency, let's say you're getting this, it's because your transparency is not selected. And here you can have some sort of transparency to see what is happening during our animation. Now let's go home. We are already home. Okay, let's minimize the material rendering for now, and let's navigate to our plot group, and let's select 1D plot. For the 1D plot, let's name it energy, and for the title, let's minimize plot settings for now, and let's expand title. And for the title, we're going to choose none. And for the plot settings, so let's minimize axis, let's minimize grid, and let's go to plot settings. Let's select the Y axis label, and for this, let's type energy, and let's put J for joules, capital J, and let's go down to the legend here. Make sure you have show legends, and for the position, let's choose the middle right. Okay, now let's add some data to our plot. Let's right click on energy in our model builder window, and let's choose global. And for the expression, if yours is closed, you collapse the Y axis data, and in expression, let's type in top one solid.ws. Okay, and also let's enter another, and for the description, this one will be elastic, will be kinetic. Okay. If you don't want the units, you can take them out. Really, kinetic should be here. And if you don't want any units, you can actually take them out. So let's leave these blank, and let's go and make some more changes. So for the X data, we have time, and we have units. Let's change that to milliseconds, units to milliseconds. And let's go down to the color and style. And let's change the width of our line, or the thickness of our line. Let's just type 2 here. Okay. And if we can click plot here, or we can click plot from the toolbar, doesn't matter. It will take a couple seconds to load. And here is our plot. So this shows the total elastic and kinetic energy in the golf ball. Let's go back home, add plot group, and we'll continue with our 1D plot. And let's make some changes similar to the last one. So for the title, none. For the y-axis label, we need that. So plot settings, y-axis label. And of course, we need to give it a name. And let's call that milliseconds, common or lowercase. Okay. And the legend this time, let's put that to the lower right. So we have legends, show legends, and let's make this lower right. Okay. Need to give it a name, velocity. Okay, and now let's right click on velocity, and we need to add another global. And for the y-axis data, let's give that an average. So description for average 1, that will be the club head, and average, the second average will be the golf ball. Okay, the units are fine, doesn't matter. And let's go down to the x-axis data and the units, milliseconds, and the thickness of the line. Last time we enter, but also we can use the bar and pull it to the right or left. And let's hit plot. You can hit plot. You can hit plot here, or you can hit plot here, and that will take a bit of time as well. Now our average magnitude of the velocity in the club head and the golf ball is shown. With that done, let's create the golf metrics. So let's navigate to the results toolbar and let's look for evaluation group. So here we have evaluation group. Let's select that and let's give it a name, golf metrics. And for the data set, here we have data and we need the last, let's choose the last time selection. So that should be at 2 milliseconds. And let's right click on golf metrics and let's choose a point evaluation. Let's go home here and let's, for the expression, let's type tangent and let's enter c over x. I think we should use the common z, or lowercase z. And the units, let's use degrees. And the description is a launch angle. The launch angle is the angle of the ball relative to the ground after impact, and the smash factor will be the speed of the ball divided by the club speed. So we'll see this in the table, so let's go ahead and generate a table. So let's go back to the model builder and let's right click on golf metrics and let's choose global evaluation, and we're going to enter some important expression. Remember, you can always pause the video and enter these expressions. Make this a bit bigger so you can see. Okay, so for this one, let's use miles per hour, mph, and this one, resolution per minute. And let's make some description. Let's call this one the ball speed, and the smash factor, and the spin rate. Okay, and now let's go ahead and evaluate, and the same process apply. You can click it from here or here. And here we have our table that shows time, and this is 2 milliseconds. It shows our ball speed in the time of the smash. It shows the smash factor, and it shows the spin rate. So as you notice, we are not seeing our launch angle. Therefore, let's go back up to point evaluation, and here let's go to selection list and let's select 165 and click add, and go back to our model builder, and let's go back to the global evaluation and let's evaluate one more time. That concludes our results. So let's go over or analyze our results. Let's start at the top. So let's start with the material rendering. And let's now go to the YZ axis. And let's make this a little bit smaller. Let's make our table a little bit smaller as well. And if we use the left mouse button, rotate a little bit to your right mouse button, pan, rotate a little bit, zoom a little bit, and now let's change the time here, and let's go to 0.3 milliseconds, this one. Okay, and let's hit plot. And let's pan a little bit and rotate. And here you see we have the golf club coming into contact with the ball. So this shows the deformation of the golf ball and the distribution of the third principal strain in the interior part of the ball at 0.3 milliseconds. So the third principal are compressive strain. Okay, so that's it for this one. Let's go down to the contact forces, and let's change the time as well to the same 0.3 milliseconds, this one. And of course we need to hit plot. Takes a while to load. So now that it's finished loading, you can zoom, and here we see all the contact forces acting between the ball and the golf club. Okay, and now let's go down to the energy and then the velocity. So our table showing the total elastic and kinetic energy in the golf ball, and this one showing the average magnitude of the velocity. And we have our table right here that shows the golf metrics, which is basically the measurement of the performance of the player and the equipment. Okay, so this concludes our study. Bye for now. Thank you for watching. Remember, whatever you do, do it well. See ya.